the calculator yet. So a piecewise function, you have two pieces or three pieces. So you have this 2x plus 3, and then you have 2x minus 3, and they're defined on different intervals, okay? So what we want to do on this is we're going to go ahead and to begin with, I'm going to go ahead and have you fill this out. We're going to do this piece right here. So there will be a table of values that I gave you like this. Now here's the key thing that you have to do when you do this is you're only doing numbers that are less than 1, but you have to start at 1, okay? That inequality doesn't have an equal on it, but it's getting close to 1. So a mistake students make a lot of times is they want to go to a number less than 1 like 0. So you want to go ahead and put 0 there, but you also want to put 1 there, and then you want to put a little open bubble kind of as a note to yourself, because that's where this piece comes to an end, and it's going to be an open bubble, okay? Because when you get to x equals 1, it goes to the other piece, okay? So now let's just pick some other numbers that are less than 1, like -1, -2, and that's good enough, okay? Now, like I said, it's arithmetic and plotting points. So does everybody understand why I chose the numbers I did? 1, 0, and so forth. Because the problem said x has to be less than 1. That's why I chose that. Now, hey, you can do arithmetic. There's nothing to this. You do 2 times 1 plus 3, that's 5. You do 2 times 0 plus 3, that is 3. And then you do 2 times -1 plus 3, that's going to be 1. You could use your calculator if you had to. 2 times -2 plus 3, and that would be -1. Okay, so you've got your points. Now what we're going to do is we're just going to plot these points then. Okay, everybody okay with what I'm doing? Okay, and the key thing is you've got to understand why I chose the x values that I did. Now go ahead and plot your points. So we're going to go to the point 1, 5. But when you go to that point 1, 5, put an open bubble. It's got to be an open thing there. Okay, because when x is equal to 1, it's going to be on the other graph. Okay, and then just graph the rest of them. This would be 0, 3. You're going to have -1, 1. You're going to have -2, -1, and so forth. Okay, now the mistake students make, I see it all the time, is students want to go through and draw the line in both directions. That's totally wrong. The line only goes that way. Okay, because x is less than 1. So do not graph anything there. Simply go like this, and then put your arrow that way. Okay, I see that all the time. Okay, it does not go to the right. Does that make sense to everybody why that is? Okay, the key thing, it said x is less than 1. Okay, when x is greater than 1, it's a totally different graph. Okay, so what we do now on this other graph, what we'll do with here is we're going to make a table of values, but this time if you read the piecewise function, it said x is greater than or equal to 1, okay? So where do I start? What's the first number I use? 1, exactly, okay? And that's going to be a solid dot because of that equal to bar. So when x is 1, it's on this line, not on the other one. Now, what's the next number you think I should use? 2, yeah, there you go, just anything bigger than 1. 2, 3, 4, you can do as many as you want to, but it's a line anyway. Then we do arithmetic, so we do 2 times 1 minus 3, which is -1. Then we do 2 times 2 minus 3, which is +1. And 2 times 3 minus 3, that would be 6 minus 3, so that's 3. And then 2 times 4 minus 3 would be 5, like that. Okay, you can go pick another one if you want to, but there's no point. If it's a line, all you got to do is have 2 points anyway. Okay. So now you want to go to your graph and you want to graph the point 1, -1, but make sure that that's a solid dot. And then you got 2, 1, and then you've got 3, 3, and 4, 5. Okay, now let me ask a question. This is what students always mess up on. Does the line go to the right like that, or does it go both ways? Only to the right, okay? If you drew it that way, it wouldn't even be a function. It would fail the vertical line test. So whenever you create a graph of a function, it's got to pass that vertical line test. Okay, so that is what your piecewise function looks like, is like that. So that's the first thing that you want to make sure that you're able to do well. And see, that's not hard. If you know what values to choose for x, there's nothing to it. Okay, everybody okay with what I did there? Okay, So I think the easiest way to learn to do a piecewise function is just make a table of values, seriously, okay? So what happens on this then is we're going to do some limits then. So again, I showed you all last time how to fill in this table of values, okay? Now, and I'm not going to show you anything on the graphing calculator on this yet, but what you could do is really all I'm doing is if x is less than 1, I'm really looking at these numbers right here, right? Those numbers are all less than 1, 0.99 and so forth, but they're close to 1. Okay, so I mean, I could do this. I could go 2 times 0.9 plus 3. Again, I'm plugging into that top function, and that's how I get a 4.8. Okay, because if x is less than 1, you plug into 2x plus 3. All right. Now, if x is greater than 1, which would be these numbers right here, then you plug into the other function. So for instance, you would go 2 times 1.001 and then minus 3, and then that would end up giving you that negative 0.998. Okay, that's where I'm getting those numbers. Okay, so if x is less than 1, where do you plug it in? 2x plus 3, right? If x is greater than or equal to 1, where does that go? 2x minus 3, okay? That's that inequality is incredibly important in the problem. Now, we talked about limits last time, so let's just kind of see what we remember on some of these things. Part B, I'm going to start with part B. This says x is approaching 1 with negative. What did we learn last time? What kind of limit is that? Left-hand limit, okay? So this is a left-hand limit, and what a left-hand limit basically means is you're coming from underneath. So look at the y values. Remember, the answer to a limit is a y value. Look at these numbers, 4.8, 4.98, 4.998. Where is it going? It's going to 5, okay? So that thing is approaching 5, so that left-hand limit is going to be going to 5, okay, like that. Okay, so the table will tell you where it's going, okay? The closer you get to 1 from underneath, the closer you get to 5 for a y value. Okay, all right, and then part C says x arrow 1 plus. What did we learn that meant? That was the right-hand limit, right? Okay, so here's the right-hand limit right here. Get bigger. Where does it look like this is going? It looks like negative 1, right? Negative 0.999 is real close to negative 1, so that right-hand limit is going to negative 1. Okay, so that's how that goes. Now, you can look at the table that way if you want to, but you could also actually just kind of look at it this way if you wanted to, okay? Like we're interested in the limit as x is approaching 1. So sometimes I'll tell students, just draw like a vertical line through 1, and then the left-hand limit, all it really means is as you're coming from the left, as you get real close to x equals 1, doesn't it look like that's going to 5? Okay, that's what the problem says, okay? For your right-hand limit, you get on the right-hand side of x equals 1, and the closer you get to x equals 1, does that go into negative 1 for the y value? Okay, so you can do that either way. The table of values will answer the question for you, or the graph will. Okay, all right. Now, what is this? If it's x arrow 1, what did we learn that was? That was a two-sided limit. Do you know what the answer to the two-sided limit is? What? D&E does not exist. We said that the only way a two-sided limit can exist is if they both go to the same place, and they don't. So this one, you just put D&E for does not exist. Okay, so that's how you do that problem. Okay, so the big challenge students a lot of times have on piecewise functions, to me, is just maybe not really understanding what that inequality means. Two pieces, there's numbers less than 1, there's numbers greater than or equal to 1. Does anybody have a question about why one of them is an open bubble and one of them is a solid? Okay, what if they were both solid? Would this thing be a function? No, because it would fail the vertical line test. So you always got to have, if it's a function, one of them open and one solid. The solid one's got the equal to bar under the inequality. That's what it is. Okay, all right, are we good? Okay. All right, now I will eventually, kind of on the next page, I'll show you how you do this on a graphing calculator also, but personally I think it's easier to do these things by hand. So this theorem down here, we really already talked about this. all it really says is it says if you have a left-hand limit, I'm just putting LH for left-hand, and then if you have a right-hand limit, and if they have the same answer, then the two-sided limit will also have that answer. We've already learned that. It just says if the left is the same as the right, they come together, so the two-sided should also have the same answer. So typically that's what I did when I'm going to do on these problems. Is I'll do the left-hand limit, I'll do the right-hand limit, and if they're equal, then I automatically know the answer to the two-sided limit. Okay, you with me there? Okay, all right. Okay, so we're going to work a little bit more with piecewise functions. Let's go down to this one. I'm going to do this one by hand, and then I'll teach you how to do this on the calculator, okay? It's nice to learn how to do these things on the calculator too, just kind of to check and everything. Okay, so with this one, ultimately what we have is we have two pieces. This first piece is the absolute value of x, and that occurs only when x is less than 0, okay? So we're going to go ahead and graph that. So let me just kind of see where you're at with this now. What would be the first number I'd want to choose if it says x is less than 0? No, 0. I'll call it -1. You're thinking right, though. You have to start at 0, and then you represent that with an open bubble. Don't forget to do that. Students do that all the time. Yes? No, okay, because see, keep in mind, here's why students don't do this well sometimes. Isn't the number -0.0001 less than 0? That's why. Okay, so that's why I'm going ahead and using 0, because you know that there is no first decimal number less than 0. That's why. Okay, people are always kind of thinking about whole numbers when they're doing this. You got all these decimals. Okay. Now, now you're going to use numbers less than 0, like -1, -2, -3, and then whatever. Okay, like that. Okay. Now, just do your absolute value. So, and absolute value, I'll give you a real quick little thing on this. I think on your algebra review, I think I put 2 problems on. There's nothing to it. If you have an absolute value of a negative, what do you know about that? Just goes positive. What if you have an absolute value of a positive number? Just the same. How about absolute value of 0? 0. What absolute value means is it means how far is a number from 0. And distance is a positive number. There's no such thing as negative distance. So the idea is all of the number -1 is 1 unit from 0 and so forth. That's what it really means. So what you get here is absolute value of 0 is 0. And you can do this all in your head. You don't have to write this all down necessarily. So that would give us enough values to draw that part of the graph. Okay? All right. Is everybody clear why I used 0, -1, -2, and so forth? That is the key. Okay, now plot it. So plot the point 0, 0, but use an open bubble. That's because the x less than 0 did not have an equal to bar. And then you got -1, 1, -2, 2, -3, 3, and I'm only going to draw to the left. I don't draw anything over like this. The mistake that students make constantly on this is they do it like that. No, okay? That's why that inequality is there, see, okay? So just make sure that you're paying attention to that. So there you are. That's what the graph looks like when x is less than 0, okay? Now we move to the second piece. And now we're going to only use numbers that are greater than or equal to 0, okay? So what's the first number I need to use on this one? Is that going to be a solid dot or an open dot? Solid, good, okay? So that's how that goes. And then we just pick numbers bigger than 1. Now, it's a square root, so I'm not going to pick 2. I'm going to go to 4, just because square root of 4 is 2. If you pick 2, I don't care, that's fine. Square root of 2 is 1.4 or something like that. Then I'm going to do square root of 9, okay, just because I know what it is in my head. So if I do square root of 0, that's 0. Square root of 1 is 1. Square root of 4 is 2. And then finally, your square root of 9 would be 3, okay? And then we'll go ahead and just graph those. I'll do that in a different color, I guess, on this, okay? So now, if I plot 0, 0, doesn't that come together with the other graph? So now the open bubble closes, okay, because they connect. So you want to go ahead and close that now. Okay, that's closed. And then just plot the rest. We got 1, 1, got 4, 2, and 9, 3. I'm just going to extend my graph out a little bit like that. So sometimes the piecewise functions will connect. And if they do that, you end up with a solid dot there like that. Okay? Okay, so that's the idea. I'll show you in a minute how to do this on a calculator then. Okay, so if you look at these now down on these limits, this one is your right-hand limit. Okay, and again, what I'm going to do on this, the best way to kind of show this on my computer is just get somewhere to the right of x equals 0. That's x equals 0. Get to the right of it. What is the y value getting close to? Remember, the answer is the y value. What y value am I getting close to? 0. There you go. Okay. All right. We never hit 0. We just get infinitely close to it. Okay. Then you've got your left-hand limit on part B. So get on the left side. Okay. Is that going to the same place or something different? Same place. It's going to 0. So therefore, what's the answer to the two-sided limit? 0 also. There you go. Okay. So if you know the left and right are equal, then you know the two automatically. That's how it goes. Okay. All right. So if you have a calculator, get this out, and I'll let you try this. I'm only going to show this one time. A lot of times students find this more difficult to do this with a graphing calculator, but it is worth learning. All right. So because you can do most of your piecewise functions we're going to do in this class pretty easily with a graphing calculator. So the idea is you need to kind of know, I showed you last class where the absolute value was. What I didn't show you yet is how to put these inequalities in. So one thing that you can do is you have the math button. So try this. If you go to second math, then you'll see it'll say test. Right above math in blue on my calculator, it says test. So if you go second math, you got that. That's where you find your inequality symbols. Okay. So if you know where to find everything, then it's pretty easy to do this. Okay, so see if you can do this. Okay, so the first graph we're going to put in, and I wrote on here how you put it in like this. So we go to y1. You want to put the square root in parentheses. So you have to go like this, parentheses, then you put square root of x, like that, get out of that and close parentheses like that. So you have to have the function in parentheses. Then you do a division symbol. Okay, you're not dividing. That's just the way the graphing calculator separates the function from the inequality. So you go ahead and put division, then another set of parentheses, then you go x, then you got to go to that test button. So now you got to go second math, and then you got to find your greater than or equal to symbol, like that, and that's greater than or equal to 0, and then do that. Okay, now what that will do, if I didn't put that x greater than 0, you would have learned in college algebra that the absolute value is like a V shape, isn't it? Okay, so it would go on in both directions. So see, if you graph that now, it's just that one piece, okay, like that. Oh, hold on, that's the square root, I'm sorry. Thinking about the absolute value. Okay, now I'm going to go back to y2, and I do the same thing. Now, the way you find absolute value is you have to go math, you have to press the math button, then you have to move the right arrow to num, and then you got ABS on that 1 right there. So you have to go like that, and then you put in your x. So it's just kind of a matter of knowing where everything is on your calculator. Okay. Then we do the same thing. We do the division symbol, left parenthesis, then you go x. Now you got to get your inequality, so you go second test, and then this one would be less than 0, so you find the less than symbol and put 0 like that. Okay, that's how you put that thing in, it's like that. And what will happen is if I graph this now, it doesn't do the entire absolute value, it only does half of it. Okay, that's why it does that. Now, to me, a lot of times it's just, to me it seems easier to just do it by hand. What do you all think? I mean, but you can do it either way. I mean, I think it's worth knowing how to do these things on a graphing calculator just if they pop up. If you're not getting your graph right, it's kind of a good thing to learn how to do. But I don't require you to do that on a calculator. It's just something I want to show you how to do. Okay, is there any questions on that or anything? Did, okay, you've got plot on. Anytime your graphing calculator has a bunch of squares on it, then if you go to Y1, you'll have when you do Y1, there will be these plots on there. All of yours are turned on, which means it's not connecting, it's doing what we call a scatter plot. Okay. So if I just go up there and press enter to take them off, then I can do that. Okay? And then don't ever turn them on again the whole semester, because we don't need to. What happens in a stat class, that you do that a lot of times in statistics. Now I would just go zoom 6, and then there you can see that thing is in now. Okay, then
okay, thank you.
Yeah, okay. Okay, let's see on here. Let's go to this next thing. I want to do a little bit more with this, so I'm going to let you all try to do this one, and I'll come around and give you some help just to kind of see how you do with this one now. So it's a piecewise function. You want to go ahead and fill out 2 tables of values. I'll walk around and you guys work together on this and see if you're getting this right. And if there's things you don't understand, talk through it. Get your graph and then answer your limits. And if you want to, you can try it on your calculator, but I don't care on that. That's just up to you, okay? And I'll pause the video. Okay, so the table of values, the one thing that you want to make sure that you do on this is x greater than 2, you're using numbers bigger than 2, and you're doing that graph of the line y equals x plus 2. So make sure you start at 2. Don't start at 3. I was kind of looking for that, but just make sure that when it's at 2, you know that it's an open bubble, okay, like that. Okay, and then the other one is when x is less than or equal to 2, so I'm doing 2 and numbers smaller, and it's got the equal to bar, so it's closed, then you want to have these numbers. You want to make sure your arithmetic is done correctly. That's the key to doing a correct graph, is to get those table of values right, and only plot those points. Don't make connect the dots that you do. Don't make it go both ways. So your graph would look like you have this parabola that I've got in green, and then I've got this line that I have in blue like that, okay? So let me kind of pause there. Is there questions about the graph? There was a few issues with some of you, but not too many. Are we okay with that? Okay. Now, if you're doing the limits now, the way this can go is kind of like this. You can just look at your graph if you want to on your limit. So if you're doing this right-hand limit like I did on A, again, I'm going to do this. Sometimes this helps students. I'm doing the limit as x approaches 2. That's why I'm doing a vertical line through 2. The right-hand limit just means get on the right side of that dashed line I drew and close in on it. So as you get closer and closer and closer to x equals 2, y is getting closer to 4. So that's how you know that, okay? Your left-hand limit, so this is your right-hand limit is over here, then your left-hand limit's over here. Trace through your graph, okay? Just start somewhere over there, and y is going to get closer and closer and closer to 2 as you hit that vertical line like that, and then the two-sided would not exist, okay, for that reason. Okay, so is there any question on that? Okay, you feel okay at piecewise functions? Generally, students do well in class, and then they start doing homework, and it falls apart. I don't want it to fall apart. Do tables of values. Make it simple. Arithmetic and plotting points. If you can do that, you got it. Okay, all right? And if you want to use your calculator, you can as well on that. I liked this joke. I saw some of these jokes I see online are kind of stupid, but I actually like this one. What, you want to hear a funny joke about limits? Does not exist. I thought that was cute. Okay. All right. Okay, so let's go ahead and let's go to the next page then. And we'll go ahead and do this one with the graphing calculator. And the reason I'm going to do this is because I think on WebWork there's a problem. There's a whole lot like this one that's a little different, and you might not have seen a piecewise function. What's different about this one is it says if x is not equal to 0, then you're on this graph. And then it says if x is equal to 0, then you're on the graph of 4, and y equals 4 is a line that goes like that. Okay, so this one might be a little bit tricky for you, but you'll see something like this on your WebWork homework for this. So let's go ahead and let's do this on the calculator. We're only going to graph the first thing. And I did this same function, I think, in the previous class. Okay, so what I want you to do is go ahead and put this in your calculator right now in Y1. Okay, so you go to Y1, and then you have to go absolute value. You've got to go math, number, absolute value like that. Okay, it's math, number, ABS. Then put in the 2x. Okay, make sure you're outside of the absolute value, and then divide by x like that. Now, we did this same graph. You'll see when you type graph, it should have two lines going in opposite directions that don't connect. Okay, so I'm going to go ahead and just do graph. I like to just go zoom 6 to put it in a standard window. We looked at this graph last time. Another thing I'm going to do on this is don't forget about your table of values. So if you go second graph, then you can look at your table of values. So the first question I'm going to ask you is, why do you think it says error when x is 0? I talked about this last class. What do you think? What can't be 0? The denominator can't be 0, right? Okay, so if you look at this problem, what's happening is if x is 0, this is what happens. You get absolute value of 2 times 0 over 0, and you can't divide by 0. That's why there's an error. So what's going to happen is every other y value is going to exist. So when you do this graph, it'll go like this. Notice that if you have positive numbers, like you have the point 1, 2, 2, 2, and so forth, and again, you want to put like an open bubble right on the y-axis and then go to the right like that. Okay, it just has to be an open bubble because you're undefined at 0. And then notice when you're less than 0, then you've got these negative numbers. So you would now go down to -2, and then you would graph that like that. Now this is a problem right here. I wouldn't want you. This would be a hard thing to do. I mean, you could do a table of values on it and it'd work okay, but it's just as easy to put this in your graph like that. So that's what the graph looks like. And what it's saying is if x is equal to 0, there's one other thing that you have to pay attention to on this problem. Okay, so it says if x is 0, then it's saying y is equal to 4. So it really gives you, this piece right here, what it really gives you is it gives you the point 0, 4. Okay, it's telling you if x is 0, y is 4. Okay, so that means just plot this point. Put a solid dot there, and you can label that 0, 4. So that's what the graph looks like. If x is bigger than 0, then it has a y value of 2. If x is less than 0, it has a y value of -2 like that. Okay? All right, are you okay with how that's going? Okay, now let's do the limits. Okay, this one is a left-hand limit. So just look carefully at your graph on here. Okay, so if I'm coming towards 0 from the left, what is the y value getting close to? -2, exactly. Okay, so that's the answer there. Okay, then you've got your right-hand limit. If you're coming from the right-hand side over here, what's y getting close to? Remember, the answer to the limit's a y value, so what's y? 2, there you go. What's the answer to the two-sided limit? Does not exist because they're different. They're not coming together, so that does not exist. Anytime left and right-hand limit are different, then the two-sided does not exist. Okay, so that's how that goes. Now, the thing on this is this second piece was only a point. It's just if x is 0, it's 4. That's it. Okay, does that make any sense? Okay, I don't know in college algebra if you saw any piecewise function that looked like that, but it's kind of a good thing to look at. Piecewise functions are used very extensively in economics, and the simplest example I can give you is when you do your taxes. Taxes are piecewise functions, and the reason for that is because we have tax brackets. So if your income is here, you're taxed at this rate, and then the higher your income is, the higher the tax rate is. Progressive taxation. So that's a piecewise function. Lots of things. Phone companies, a lot of times, will have piecewise functions for their charges. Okay, so it's very, very common. Okay, any question on that? Yeah. Okay, all right. Let me go ahead and let's do this example 8. And let's go ahead and do this. I'm going to work a little bit longer before I give you a break. I want to go ahead and we're kind of out of the graphing realm now. Graphing is a good way to introduce students to visually the idea of what a limit is. Now it's just I'm going to give a graph and we're going to see how many of these limits we can figure out. Okay. So with this, the first thing I'm going to look at on this row, this first row right here, this has nothing to do with calculus. This is what we call function values. So you should have talked about this a little bit in college algebra. If you have f of -8, what it means is x is -8. Your job is to find what y is. Okay, that's all it is. So let's do that. Let's locate x equals -8. What is y? -3, exactly, because there's a solid dot there. So that's equal to -3. Okay. All right. Now we go to x is equal to -2. Okay. If x is -2, what's y? That's 3 because you got the solid dot there. So that would be 3. Okay. Now let's go to 6. If x is 6, what's y? Okay. Again, the solid dot is what you're looking at. So that y value is 5. Okay. And then we look at number f of 10. So if x is 10, you're right there. What's y? 0. So all of those things is their function of values. I'm giving you x, you're finding y. And you look for the solid one, not the open one. Okay, are we okay with that? Okay. Now we'll kind of go through and we'll begin to look at some limits here. Let me erase some of the stuff that I did on here. And this is one approach that you can take if it's helpful to you. What I'm going to do is this row right here is we're interested in x equals 8. This whole row, E, F, and G. So I'm going to go to 8. I'm sorry, -8. So I'm going to go to -8. And I'm going to just draw a vertical line through that. You don't have to do this, but if you find this helpful, then that's something you can do. That way it's kind of a boundary. It's like a wall. Okay. So now we can figure this out like this. The first one, E, is a left-hand limit. So what we can do is just get on the left side of -8 and close in. Okay, now the question is, what is y getting close to? What? -6. Okay, students all the time think that the answer to the limit's -3. It is not. The answer to a limit is the number you're getting close to. Once you hit -8, you do jump there. But if you're barely to the left of -8, you're close to -6. Remember, a limit is only what you're getting close to. So that limit right there would be -6. Okay, like that. Okay. Then you've got your right-hand limit, which means get on the right-hand side of that vertical line I drew and ask yourself the same question. Again, what is y getting close to? -6. It's the same thing. It doesn't matter that there's an open bubble there because the limit is only what you're getting close to. Does that make sense? I'll keep saying that over and over again because that's what you have to have in your mind is a limit is a y value you're getting close to. All right. So what's the answer to the two-sided then? Okay, there you go. Okay, so if the left and right are equal, then that automatically gives you that limit. Okay. Okay, now the next row, it looks like we're interested in x equals 6. So I'm going to take the same approach, and I'm going to just do a little vertical line through x equals 6 and see if that will kind of help me visually see how these limits go. Okay, so on h, I've got a left-hand limit. Get on the left side of the wall, not way over here, just a little bit to the left of it. Okay, what is y getting close to? Y getting close to what? 2. So that's your left-hand limit. Okay. Now you got your right-hand limit. Okay, get on the right side and close in. What is y getting close to? 5. There you go. It's only what it gets close to. It makes no difference whether that's an open bubble or a solid. You don't even pay attention to that. What's the answer to the two-sided? How come? Why does it not exist? Because they come to different places. Your two fingers don't come together. So that does not exist for that reason then. Okay, so that's how you do that. Okay, and then this last row, now I'm going to look at x equals 10. So I'm going to kind of take the same approach. I'm going to locate x equals 10, and I'm going to do the kind of a vertical line like that. Okay, and we'll kind of talk them out. Left-hand limit, what am I getting close to? 0. Okay, right-hand limit, what am I getting close to? 0. So 0, 0, what's the two-sided? 0 also, very good. Okay, so that's how you put that together. You got to look at the graph the right way. So my recommendation is, if it helps you, just whatever x is getting close to, make that your vertical line, and then just look at the left and look at the right. And the answer is a y value. Don't forget that. Limits or answers are y values when you're getting close to a specified x. Okay, so I'll put you to work on these, and we'll go over these, and then we'll take a break as soon as we're done with this. So let's see what we can do on this graph. A few minutes to kind of look over that and correct anything that you missed. If you got them all right, congratulations. That's a good start on limits. That means you're kind of getting off to a good start with understanding the concept. I did help a lot, I think, on like there was a couple on here that showed up that some of you are confused about, like that one being undefined, that one being 1, those two right there. I had a lot of questions on that. All right, do we have questions or anything so far? Okay, all right, we'll go ahead and take a 10-minute break. So just come back at 1:10, and then we'll go to the next part of this where we do limit laws. We're kind of now going to be away from graphing and doing this a little bit more algebraically, okay?